Hello, everyone, and welcome to my YouTube channel. Welcome you all for this particular workshop on containers and Kubernetes security workshop. Basically, we have been doing a series of workshops on different topics. So, we started with Linux and Docker, that went for 6.5 hours. Chad took the workshop, and then I took the Kubernetes 101. Then we had the GitOps fundamentals with certification. So that was the third one. And today in that series, we are continuing the fourth one, which is containers and Kubernetes security, which is like absolute and hour of the need. Especially the security is very much to be thought from the beginning, not something that has to be thought in the end after doing everything. So, and that's where today's guest Revant will be talking all about container and Kubernetes security. So the only thing is that this is again, yeah, all of our workshops are hands-on, and this is no different. And big shout out to Revant. He has not been keeping well for quite some time, like 10 days or 15 days, but still he didn't back out because he wanted to do this for you people. So I would request everyone to immediately share this workshop link on your socials and get the maximum audience so that more people can learn from this particular workshop. So thank you all for tuning in live. Please stick till the end because I am pretty sure that Revant has prepared some great stuff for you people, especially in the security space. And this is very interesting topic when it comes, Kubernetes security or container security, the basics, the understanding. It's very much required to understand, and you'll get all your concepts clarified. Again, to those who asking, the prerequisites for the workshop are the past workshops, especially the Linux, Docker, Kubernetes. Those stuff, at least you should be knowing the basics of that, if not the complete level. And yeah, so we can now start with the workshop. Over to you, Revnath. Revant, please introduce yourself to the community and let's get started with container and Kubernetes security workshop.
Thanks, Ayam. That was an amazing introduction. And so, welcome everyone for the workshop on container and Kubernetes security. So, currently, I'm working as a senior security architect at Emirates NBD. That's one of the leading banks in Dubai, where I specialize in complete infrastructure security that mostly involves Kubernetes and cloud native components. And I'm also a speaker and trainer at multiple international conferences as well across the globe, where I present my work in the field of security. And I was also part of some bug hunting researchers or bug crowd programs where I was recognized as the MVP researcher. And I was part of Google Summer of Code, where I contributed to Nmap and multiple other things. So you can just see more about me here. Let's dive into the workshop. So you can access the workshop from this link, and it is accessible. It is available even in the description of the YouTube channel. So when it comes to Kubernetes security, it's just not the misconfiguration in Kubernetes. We eventually run applications on top of Kubernetes that leads to any kind of vulnerability. So for example, these are a couple of hacks that happened over the past few months or years that led to critical issues on top of Kubernetes. For example, you see this, there are over 900,000 Kubernetes instances that are exposed online. And similarly, there is a Tesla. As you all are aware, Tesla is the leading company. And even because of some minor misconfigurations in Kubernetes environment, it has to see the downside, and the stock crashed badly because their entire servers were exposed outside and the crypto mining was happening on them. And like I was saying, this one is not related to Kubernetes, but it relates to the underlying components of Kubernetes, which is the container runtime interfaces, where if an attacker got access to one of these containers or something, he can easily break out of that. And similarly, many more. Even this one is related to Prometheus, where Prometheus servers were exposed, and using that, the attackers can come inside and they can break out of the containers, gain access to the host machines, and several other hacks that are available. So, why it is being done? First thing is because of the increased complexity when it comes to Kubernetes and the application management. Application is managed by a different team, and the infrastructure is handled by a different team. So there is no proper joint between them. That's the reason, like Siam has already mentioned, it should be a before thought. Security should always come when the design gets started out. So for example, I'll show you how it is done. So this is not a hands-on thing. I'll just show you how an attack happens in real world or how an attacker looks for it. So for example, this is one of the most famous website that scans the entire internet, Shodan, the internet for all the open servers, and it will identify the open ports running on the systems across the globe. All the IoT devices, it will scan for it. And then you can search for things like, for example, I want to check what are the services that are exposed on port 4040. I can search for it and it will. So I got a premium account. So it is a very small cost. You can pay $5 and you'll get a lifetime free subscription. So right now, if you can see, there are like multiple results that are exposing 4040 across the globe. So similarly, let's say since I'm from India, I thought I'll check for 4040 open ports in India within Mumbai, and then it will return me a bunch of results. Sorry, there was some typo, I guess. So even if there is a minor typo, you won't get in the results. So once you do that, yeah, so you get multiple results, and now I can click on here Mumbai, and then it will show me all the results in Mumbai. And once you do that, or there is this amazing website that you can access where you'll have all the filters related to Shodan that you can use. I have added it, included it in the same page, so you can go through that later on. And I found this interesting website, I mean the server, where they're exposing port 22 and 4040. So I was just curious on what's running on this 4040 port. So we just go inside here. Right now I just logged in. In fact, it was protected with authentication. For example, if I show you in incognito mode, it will ask for authentication and authorization. Now, if I don't enter anything, it says this unauthorized. So there are some amazing tools like WFirst, GoBuster, DIRBuster kind of things where you can use those things to brute force the username and password. But when you have to brute force the username and password of a website, you need to get a list. And Daniel Missler has one of the amazing lists ever on GitHub. So what I had done was I went to this and I identified some of the most used passwords in 2020, ran a brute force against this specific website, and then I was able to access the complete system. So this is Weavescope. It is an amazing tool from the WeaveNet community. So if you just see a bit about it, it is used for monitoring, visualization, and management of Docker and Kubernetes. So you can visualize your entire cluster, all the containers which are running on your system, and then you can even do a couple of more things. So what's interesting about this is it is exposed to the internet and it is protected with authentication. But since they are using a weak authentication or the common passwords, so we were able to use a common passwords list and I was able to brute force into the system. And now let's say we got multiple containers here. And the interesting part is if I just click on anything, it will show me the container name and everything about that. And also there is an amazing feature here within the tool where you can get a shell within the container directly. So you will be able to access the container as well if this tool is exposed outside. But you are still lying within the container. So if you do something, it will just impact the container. It will not impact the host machine directly. in order to access the host machine or the files on the host machine, you'll have to break out of this container. But there are some certain things that you need to look inside the container when you want to analyze it and understand how it functions. So that's what we will see in today's workshop. But before that, I'll just give a demonstration on how it is done. For example, since I have enumerated all these containers and analyzed all the files, their specific configurations, and I found out this specific container to be interesting where it says view scope. Then I just went inside that. And if I just look for the capabilities, it is not existing. So usually we use apt update or something, but apt is not there. So you can look for
Can
with
you
a random.
increase the font? Can you increase the font size a bit?
Sure. I'm not sure if it. Let me just zoom in.
Yeah, zoom in browser. That should work, I believe so. Yep. Thank you.
Okay, perfect. So now it is having APK because it's a different shell. So we can just say APK add. Even I've libcap if we want to identify these capabilities. So we can just go and say you can see there are multiple capabilities. We'll go in detail what these capabilities are and how these will help us in understanding what it is doing. And also first thing is we need to understand if we are inside a container or if this is the host machine directly. So there are some couple of things we can check. For example, since this is all being run, we have seen multiple containers in this interface. So we can go and check the Docker folder. So here there are no instances of the Docker files or the cache available. So we can be sure we are inside the Docker. But now we need to identify a way to break out of this specific thing. So what I'll do is, since you have seen all these capabilities, it is having way too many capabilities than it actually requires. So we can consider this as a privileged container. I have included in the session how we can identify if specific thing is privileged container or not. We'll go through that later on. And there are some other things that you can look for example, Docker socket. So you can see there is a Docker socket available already, which is mounted on this thing, which is a very bad practice to do because you can leverage this specific socket and you will be able to identify the things. So we don't have Docker either. So we'll just say add Docker. And now if I do Docker PS, I am able to see all the processes which are running on the host machine. Or if I do Docker images, for example, so there are some Golang images, Node, BusyBox, whatnot. So now I'm able to list all these things. Since I have access to the Docker, I can even run my own containers. So for example, there are some other tools like NSEnter as well, in which you can create your own namespaces in Linux, and you can even hook into one of the existing parent processes. So if I do some processes as well, it will have way more processes than the actual thing. So you can see all these things. And now let's see how we can break out of. Let's not break out of it for the time being. What we will say is you want to access the host machine. You have checked here and this specific folder is empty. It doesn't have any of the Docker related components. But when you did Docker PS, you can see multiple components of Docker available. So ideally there should be some files in this location. So what we will do is we'll try to run a privileged container. So you can run it with this command and let's say ubuntu, for example. So what I'm doing is I'm running and I'm getting an interactive terminal in an Ubuntu image called bash. But this will not help me anything because I'm already on a privileged container. So alternatively, what I will do is I'll mount the complete volumes of the host system. So what this will do is the entire host system, it will copy to this. It won't copy, it will add a mount point to that specific location. So here, if you see, you have the entire root system of the host machine because Docker daemon runs on the host machine. We'll go in detail, so don't get confused about these things. So now if I go to where lib Docker inside this ABCD thing, so You can see there are multiple containers, images, networking, overlays, everything available. So in this way, an attacker will be able to access the entire host system. So let's say right now you can just got access to the files on the host machine, but you want to gain access to the entire terminal. So in that case, you need to find a way to run process on the host machine directly from here. There are multiple ways to do it. And one of them is by getting a reverse shell. So what is a reverse shell? Usually this is how the attack looks like. An attacker tries to establish a connection with the target, but there will be a firewall which will be blocking all your connections. So firewall, we have network policies in Kubernetes which can similarly block these kind of things. We'll look into that as well. So this is a normal connection, but what happens in a reverse shell is you will open a shell, or you will wait to catch a connection, and you will try to run some commands on the other machine, and it will initiate a connection towards you. So for example, how it is done, what we can do is we can leverage cron jobs. So if you have tried exploring more of Linux before, so there are these locations like cron tab. Come on. It's cron tab -L. It will list all the available cron jobs. And similarly, we have a location called etc/cron tab. What this does is it will have all these information available, and it will execute the cron jobs at this specific period of time. So what we will do is, since we can mount the complete host system into this ABCD location, we'll go inside this, and right now we have access to the complete directory of the host system. So we'll go to etc and we'll see this cron tab file. So if you see here, it is having the generic things. So what we will do is we'll try to add some more things over here. So what it does in real world, maybe we can go through that later on. I'll just give on a high level brief because this is not the main focus of the session. I just wanted to show it is possible and how it is being done. So if you see this command, what this is doing is it will open a socket connection to this specific IP address on this port. So I have my own Linux instance running over here. And if you see I'll just zoom in a bit. Yeah, if you see, this is my public IP address. So I'm using the same IP address over there. And then I'm saying connect on this specific port 8888. So what I'll do here is there is a tool called netcat, which is from Nmap itself. And it will help you to do a TCP UDP connection establishing, or you want to debug something, so you can use that. So what I'll do is I'll say listen on port 8888 for any of the incoming connections. So right now I have executed this and I have stored it in temp run.sh. So now I'll just make sure it is executable. Since I'm putting in ABCD, it is ideally on the host machine. And then what I will do is I'll run this command. So what this is doing is it is saying every 1 minute. So there is a nice website called Cron Tab Guru, I guess. So you can visit this to understand more about cron jobs. So if you have seen, I have given something like this. So it means execute the cron tab every minute. If I am giving 1 or 2, it keeps on changing. You can explore more on cron tab through this website. What I'm saying is every 1 minute, execute this file bash/temp/run.sh. Since this one will be running from the host machine, I'm not putting ABCD over here. I'm just saying directly going to temp and execute this specific file. And also just for the testing, what I'll do is I'll run this command as well, where I'm saying every minute, send a curl request to this specific IP on port 8000 with host name value, so that I can know if you see host name, this is the host name of my current machine, which is definitely not the host machine. So what we can do here is I'll just kill this. I'll open my tmux, or I think it is looking. So I'll say 8888, and I'll just wait for a while. And similarly, I'll run a Python server where I'll say I'll open an API connection on port 8000. Now, if we just wait for 1 minute, and then we should be able to see a connectivity over there. If you see, I have written bash temp run.sh, and we are sending out a connection here. So once we wait for a minute, and in the meanwhile, you can explore more of this or see if there is some other things available. For example, the passwords, we can see like what are the usernames available and what kind of passwords are there, and you can even print the shadow file. So now you have the shadow file. This is another way where you can leverage this thing. For example, you print etc shadow, and then it will have all the username password information. So what you can do is you can modify the password of one of the machines. And if you remember, when we saw through Shodan, the port 22 is also open. So you can easily do an SSH connectivity. You can go and make changes to the SSH configuration, and then you'll be able to get a remote. So you can see there is a hit from the specific IP. I'll just zoom out for a minute because I cannot see much. But yeah, as one second, it got crashed for some reason. I'll just check if I'm having some other processes running on these ports. Just installing the net tools, and then I'll use the netstat command to check if I'm already having something on port 8888. And apparently I have multiple things running. So I'll just terminate all of them. Yeah, or you can see here, if I just zoom in a bit. So, and so we are getting a hit from this host machine because in this etc cron tab, we are sending out a curl request. And similarly, if I run the netcat command, I'll be getting a shell as well directly over here, and then I'll be able to access the things. Then I'll have complete access to the container. We can just try it out quickly. If I do this and wait for a minute, once we get another hit here, we should parallelly get a shell. But in the meanwhile, we can continue with the process without wasting the minutes. So this is one of the attack method framework that created by Microsoft and multiple other people on what are the things that can happen or what are the different stages of execution when it comes to Kubernetes security. First thing is gaining initial access. So here we are saying the cloud credentials could be compromised or application vulnerability can be there. That will give initial access to the attacker. Once he gets the initial access, he needs to do an execution. He needs to execute into the container or find an application exploit or remote code execution to break out of the container. Once he breaks out of the container, you need to gain persistence. So we have done that through cron job. Once we have persistence, we can try to escalate the privileges. Right now, we don't know if the specific thing is being executed by root or non-root user. So if non-root is executing, then once you get the terminal access, okay, if you see here, we got another hit, and parallelly we got another shell as well. So if I do host name here, it is a different host name. And also I can do process -ef, and then we'll be able to, I'll just zoom in a bit, maybe 1 second. Yeah, so if you see, we can run all the commands and we got access to this specific machine. If I do docker ps, you can see Ubuntu, vworks, Ubuntu. So there are around 7 containers running. In order to validate, if you want, you can just come here, do docker ps again, and you can just check the word count, number of lines, for example. There are 8 lines, so there are 7 processes that are running. And the same over here. So now I have complete remote shell access to that machine where I'll be able to do anything. And if I check the permissions of me, that is being executed as a root. So that's how I'm able to get access. And now I don't need to do any privilege escalation or something. But I think this gives the gist on how an attack can be done or how the real world attacks happen. So people continuously monitor for these kind of websites where it lists on all the servers and other things. And then they try to enumerate the systems, understand the vulnerabilities in it. And then they can break out of the containers. Now, once I have access to the system, I can do anything. I can DOS the system, or I can try to run some malicious commands, or I can even try to change the existing processes. Or for example, there are many Docker images, if you have seen. So I can just go and try to, okay, change these Docker images, and then I can replace them with some malicious images. So when the user tries to install that, instead of the actual image, he will be running malicious image, and so on. So there is no need of privilege escalation for us, but that is one of the things which you have to do. And similarly, once you came inside, you need to make sure you clear the tracks. So like clearing out the container logs, deleting the kernel events, deleting the Kubernetes events. And similarly, there are other things, credential access, discovery. Once you have access, right now we just got access to this machine and I left it. In real world, how it is done is once you got access to the machine, you'll see if there are any connecting machines. If this machine is communicating with some other server, and if it is connecting, then you will try to escalate into the other server and then compromise that. And if there are some private registries running within these servers, you can compromise the private registry, and the impact would be very high. So these are different stages how you get access to one of these vulnerable machines or vulnerable application, and then you escalate step by step till the last phase. But we cannot cover all of these things in a single shot. So what we will try to do is we'll try to touch base with each of these, one attack in each of these scenarios, so that you will get a gist on how it is done. And if you want to read more about this thing, I have referenced the link as well. So you can go to Weebworks and you'll be able to get all the information on this specific attack matrix that will help you to understand more. So since we have seen multiple things on how it is done, the first thing would be, what is a container? So container is basically an isolation within your host system with unique namespaces. Linux is an amazing creation where you have multiple things in it, which we know very little of. So whenever a new container needs to be created, it creates these many different kind of isolations. So it will create a process ID isolation. It will create a user isolation, mount isolation. So for example, so from here, it will be a hands-on session. So if you want, you can start out with, killercoda. I'll just open that. Playgrounds. Yeah, so in the meanwhile, so I was saying there will be multiple isolations created within the container to make sure it does not expose itself to the host machine. So whenever you are running a container, for example, I'll just zoom in a bit. Docker run, let's say I'm running an Ubuntu machine, for example. I will just pull it. So it will create these multiple isolations. For example, process ID, you can see the process of only the things running in the container. There will be multiple processes running on the host machine, but you cannot see it because of the PID masking. And similarly for user IDs, it will have different set of users, mount points. It will have different set of mount points. For example, if I do PS, I can see only 2 processes and it says this is the root process. But if I open a new tab, and if I look for processes that are running on the main machine, there are so many. Because of this PID masking, it cannot see any other processes. Similarly, isolation of networking interfaces. So if you look for if config, IPA. Okay. There is an amazing website called command not found, and you can just go and type in the command that you are unable to find, and it will show you what you need to install. So in this case, I need to install NetTools in order to get this thing. So I'll do apt update. Then I'll just run this command NetTools. Now if I do if config, you can see there are two interfaces. One is running on 172 dot something, and the other one is the loopback address. But if I run the same command on the main machine, you can see there are multiple interfaces. There are virtual Ethernet interfaces and Docker interfaces and a lot more. With this isolation, container creation is being done. Similarly, you'll get a unique host name. Ideally, the host name of your machine is different. So right now, if I check for the host name, this is the host name of my container. But if I go to the host machine and if I look for host name, it's something else. So this entire thing is being handled by Linux in the background. So we have already executed this command. So let's say if I'm coming into this container and if I'm doing sleep one day, this process is being executed within the container. But like I said, it is just an isolation created by the host machine. So if I go to the host machine and if I look for all the processes, psaux will list all the processes that are running, and then I'm looking for the sleep command. So if you see here, sleep one day, this is the command we executed within the container, but we are able to access it from the host machine directly. So now if you see, this is the process ID that is given to that. So now what we can do is, there is a location where all the processes information is stored within Linux. It is called proc. So if you see, there are multiple information or processes information available here. Since we are interested in sleep one day, I'll copy the process ID of that and then see all the information related to the process. This is all the information related to it. So if I go to the namespace, you can see these are the different namespaces that are created for this specific process. So it has its own C group, IPC, mount, and everything. And if you expand, they'll be pointing to different C groups or IPC mappings. So as you can see, this Docker container namespace are created, but everything is existing on the host machine. So for example, even better thing would be, let's say we are running this command. We are saying, we'll just run the container. I'll just kill this shell because it's no longer required. Let me just copy it again. So what I'm doing is I'm running a container with name debug container, Ubuntu, and I'm getting a bash shell. And here, if I'll create a file. Okay. And this is inside the container. If you see, we are inside the container. And now let's try to access this file from the host machine. So how can you do that? So first thing is, there is a command called docker inspect that will list you all the information related to a container. And if you do docker ps, we have already given the name as debug container. So we'll just use the same docker inspect, and then you'll get multiple details. Let's not worry about all of them. So what I will do is I'll grab for dir. And you can see there are multiple directories information we got. What we are interested in is upper dir. These both are the important things. So what happens is the lower dir will contain all your base files. Whenever you run a container, all the files related to that specific image are stored in this location. And whatever changes you make on top of this container, for example, creation of this file, it is a change on the base image. So this will be stored in this upper dir location. So what I'll do is I'll just copy this location, upper dir value, and then I'll paste it. So you can see there is a file.txt inside it. So let's say if I change directory into that location and I do file.txt. So it's inside the container. But in real, we are on the host machine. So what I'm trying to explain is, whatever things you run within the container, they will eventually get executed or available from the host machine directly. Containers are just an isolation. It's not secure, or it's not like if something happens in the container, it will affect only the container. If executed in a wrong way, it can impact the host machine as well. So that is a bit about what it is to be in a container, or where the details of the container are stored. So now let's see, what does it mean to be root inside a container? Like we have explained, it creates multiple isolations. For example, it creates a user isolation as well. So the root inside the container might not be same as the root on the host machine. So how to understand these things? For example, we'll run the same command again. So right now, instead of Ubuntu, I'm just picking nginx image because it's smaller. Let me just copy it again. Paste it here. So now once it pulls the image, I'm just doing sleep. Maybe I didn't copy, I'll just type it out. I'll say sleep 1 day again. So now if I go into this main tab and I say ps -ef or ps aux, you can use anything. If I do sleep, it is getting executed as a root user. So now what we will do is we'll try to open another terminal, and then we will create a new user. So there are multiple cases that we are seeing. First thing is we are running as a root on the host machine as well as root inside the container. So already we have seen here, if I do who am I, we are already a root. So Docker is being executed as a root. And even here, nginx default user is a root user, as you can see here. So now let's say I'll try to run Docker as a non-root user. So what I'll do is I'll try to create a new user, Ubuntu. Okay, it says already a user Ubuntu exists. So what we will do is we'll just change the permissions of the Docker socket file to make sure it can execute this Docker commands as a user. And now we'll change to the user Ubuntu. You can see now the user is changed. Now if I do Docker ps just to check if I can do it or not, I can run it. And now let's say if I'm running this Docker run, again the same command. And now if I say here sleep for 2 days, just to make sure we can differentiate between the commands. Now I'll do the same command again, ps -ef and sleep. So if you see the sleep 1 day, it is being executed as root, and sleep 2D or 2 days, even it is being executed as a root despite running it from a Ubuntu user. That's because Docker in the background, Docker daemon is running as a root user. So it doesn't matter if you are executing these commands from Ubuntu user or root user, eventually all the processes within that are being executed as root. So now what we'll try to do is we will try to run as non-root inside the container. So root on the host machine, but as a non-root from the container. So I'll copy the same command, not the same command, it's a different command with a slight modification. Copy this. So if you see here, we are running the same nginx and we are getting a bash shell, but instead we are specifying the user ID. We are saying run it as user 1000 with a group ID as 1000. And now if you see, it says I have no name because there is no such user existing, but it will still work because it is just a number to the Linux namespace. It doesn't care about the name. And now let's say if I'm doing here sleep for 3 days. Now if I go into this specific tab again, now I run for the process. If you see sleep 3 days, it is running as a Ubuntu user. So what this means is whenever you are running this Docker on the host machine, even if you are running as a root, non-root, eventually the process will be triggered as root. But when you are running a container inside without a non-root user, then whatever process triggered, they will be running as a non-root user. The reason here it is showing Ubuntu is because If you see here, we are saying we are mapping 1000 user. So now when I exit out of this thing and I came to the main machine, and if I say etc password, it will list all the users information. Now I'll just grep for Ubuntu. So you can see the ID 1000 belongs to Ubuntu on the host machine. So here when I executed this Docker command with user 1000, even though there is no 1000 user inside the nginx image, whenever it is triggered, it will trigger with this specific user. And since it is Ubuntu, it is having the information of that user over here, and it says it is running as a non-root user eventually. So whenever you run a container, make sure you're running it as non-root, because even if it gets compromised or if someone breaks out of it, he will still be in this specific user namespace. He won't be as a root. So he has to still escalate the privileges in order to do something critical or catastrophic. So for example, since Docker daemon runs as root, eventually all the processes are triggered as root that we have already discussed. So for example, let's say let's see another example. So you can kill all the other instances. We don't require them. Kill this all. Now if you see here, I'm saying I'm root. Sorry, I'm still inside the container. I'll come out of it. Okay. And host name, just to make sure I'm on the right machine. So I'm saying I'm root and I'm creating a file here, temp.root.txt. Now I'll change the permissions of it to make sure only the root user can read it. Let's say I switch over to the Ubuntu user, which we have created just now. And now if I try to read temp/root.txt, it is permission denied. Ideally, whenever you are giving access to a server, you give access to multiple people. You usually create non-root users and make sure they have the specific privileges to do whatever operations they want to do. As of now, they are not able to read this sensitive file, which is created by the root user. But since, if you see here, root created it. But since this specific user is having permissions to run Docker commands, so what we will do is we will try to mount this specific image, specific file. If you see Docker run interactive terminal, and we are saying mount this file temp.root.txt into an nginx image, and I'm just saying to print it out. So if you see, even though I am Ubuntu user, I cannot directly read the file when I do a cat or something. But since Docker daemon is running as a root user, whenever I run these commands, eventually it gets triggered as root, and root user is capable of reading these specific files. So whenever you run images with root user directly, these are the kind of issues that you can face. So for example, let's say we change the user ID to 1000 again and run the same command. It's the same. Instead of root, we are saying run with this specific user 1000. And now you see, they cannot read this specific file. So even though Docker is being executed as a root user, Docker daemon, but because you have mentioned to use this specific user or a non-root user, they cannot read this file unless they have the permissions to read it. So whenever that container gets compromised or something, they'll still have this 1000 user. So first they have to break out of that and then break out of the container to gain access to the host machine, which will be more secure. It's a defense in depth mechanism. So we can come out of this and go back to the host machine again. And now privileged container. Whatever we have executed till now, they are just the normal containers. There is something called privileged container. So what this does is it will give more privileges or permissions to your container. So what we can do is kernel files are crucial on your host machine. So let's see if by using this privileged container, we'll be able to make some modifications to it. For example, I have given a reference to one of these Linux documentations over here. There is a concept or file called swappiness. So what this will do is it will tell how much memory or RAM the system can dump or swap between the disk space and the RAM usage. So that is something specific only to the host machine, and this specific image or the containers should not have access to it. So let's see what's the value of this swappiness file. Sorry, my bad. I'll just move this over to the other side. So right now in this killercoda, the swappiness value is 0. But if I do it on the host machine, I think the value should be different because it's my host machine. You can see the value is 60. The higher the swappiness, it's better because the system can write more things to your disk space. But that's not our concern. So now what I'll do is I'll run a Docker container again. So in this case, I'm running a privileged container, a Ubuntu image, and I'm getting a bash shell. So now what happens is whenever you are running a privileged container, it will get more access than a normal container. And now let's try to edit this swappiness file, for example. So now we'll do a swappiness again. And you can see the value is 0. Let's say I want to change the value to 10. And now if I do a cat, it will show 10 because I'm within the container. Go to some other tab and try to print it again. The proc sysvm swappiness value. You see the value got changed. So whenever a container is running as a privileged mode, it will have more files that are common between your host machine and the container, and that includes some of these kernel files as well. And whenever you tamper with these kernel files, it can result in complete denial of service attacks, and it can completely crash the system down. So let's say you got access to one of the containers by exploiting an application like we did in the beginning. So how will you identify if you are inside a privileged container or a normal container? What are the key differences for you to identify? So for that, what we will do is we'll run two containers. One as a normal user, on a normal container. On tab 1, I'll run a Ubuntu container, which is normal. And on the other thing, I'll run a privileged container. It's the same one, except the privilege tag. So now there are multiple ways in which you can identify. I tried to list down the simplest ones possible. For example, you can look for the mount namespace. So not mount namespace, you can look for the mount points. So if you see in the normal container, which is in tab 1, whenever it mounts the C groups or the processes file system, everything will be in read-only mode, whatever is related to the processes. But if I run the same command in here, it will not have anything because in privileged container, it will have same access as the host machine and there won't be any read-only systems. And similarly, whenever you run the processes, it will create a temporary file system. And in a normal container, if you look for that, you'll have multiple temporary file systems for each of these processes or different process libraries. But when you see in a privileged container, it will have nothing. And similarly, you can look out for Linux capabilities. We'll see more about that in the next section. But this is not present. apt, I guess, apt update. Similarly, I'll run an apt update here as well. If you see, I cannot find capsh, so I'll just go back to this same website again, commandnotfound.com, and I'll say capsh not found. It will give you the command, whatever needs to be executed. Now, if I do capsh -- print, what it will do is it will list down all the capabilities information related to that specific container. And this one also will, if we do the same, you see here the bounding set, it is only 2 lines. So it is having a limited set of capabilities. But if you see here, bounding, it is around like 5-6 lines. So it is having much more privileges when it comes to privileged containers. So this can do more number of things. What does that mean to us? We'll check out later. So similarly, there is a seccomp that says it can limit the number of syscalls or what kind of syscalls a specific container can execute. For example, if I run it from the non-privileged container, it is having some value saying it is limited. But if I run from this specific container again, like the privileged container, the value is 0. It is same as the host machine. If you go to the host machine and if you run it over here, it will be the same. So this is how you can identify if you are within a privileged container or a normal container. So once you know you are in a privileged container, your approach would be different to how you can leverage it or how you can fix it. If it is a normal container, then the use case will be different. So I have added some references related to capabilities. So this is capabilities is something which is specific to Linux, and it says what kind of things a specific user is capable of doing or a process is capable of doing. Even every process can have different set of capabilities, and we'll see how it is done. So for example, capsh is the command line utility that we'll use to print all the capabilities. So we can just break out of these containers, and let's say we print it.
Revant, just one
Yeah,
thing. The left portion of your screen, right? The Kubernetes 1.24. You can actually slide it to the left. No, in the terminal. Yeah, you can slide it. Yeah, so that we
okay.
get more space. Yeah,
Thanks, man. I didn't try that, but yeah,
no worries.
this is helpful. I was struggling with the small screen. Okay, so when it comes to the capabilities, so we can see different set of capabilities available. So if you can see here, this is on the host machine. So if you see the host name, you're directly on the control plane machine. And these are the set of capabilities that you got. So for example, as I was saying, every process will have its own set of capabilities. For example, what we can do is whenever you run a process within the container or Linux machine, you will have a self status as well. As we have seen here, /proc will have information of all the process IDs and their information. Similarly, self is just referring to yourself. So now when I do this self status and I'm looking for capabilities, I have multiple values. So what we can do is capsh is having a feature within itself where you can decode the information or decode the specific values. For example, we'll see cap bnd. We'll see what it is in the coming slides or something. Now you can see these are the list of capabilities available for this yourself because it is a self process. So now what we will do is we'll try to correlate it with the Docker containers. So for example, we can run this command. What this is doing is Docker run Ubuntu image, and I'm saying sleep for 1 day. And whenever I'm putting an ampersand in the last, it will just execute the process in the background and it will give you the shell. So if you do this, it is done. So now what we will do is we'll try to look for the sleep processes similar to the
Revant, sorry to
yeah,
disturb you again. There is a
yeah,
request to increase the font size a bit, please.
yeah, sure. Okay, where did it go? Is it clear now?
Yeah, thank you.
Okay, perfect. So now we have executed the Docker thing, and yeah, as you can see here, psox, and we are looking for the sleep command. And this is the process ID 44450. So now what we can do is we can run the same command again, but instead of self, we will provide the process ID over there. So we'll do grep. We are grepping for cap inside this process ID. I'll just paste it, and then I'll have to look for its status. You see, we got multiple things. Let's see what they mean in the later section. So what we'll do is capsh again, decode, and you can copy this bounding value. It is like the maximum thing it can get. And you can see it got very limited number of capabilities because you are running this sleep inside a normal Docker container. It is not privileged. It's not having any other things. So it is having limited set of capabilities, like 2 lines, if you remember. So now what we will do is we'll try to run the same command sleep inside a privileged container. So if you try this, we are running Docker run privileged container Ubuntu, and we are saying sleep for 2 days. Now again, we'll list down all the processes with psox, and we'll grep for sleep. But now we need to look for sleep 2 days because that's the privileged mode. So now this is the process ID for it. So now what I'll do is grep for cap inside proc. I'll copy the process ID and then status. If you see, the values are changed from the previous. I'm not sure if I can scroll, but yeah, from the previous value, how we can identify using cap as its decode, and then we can paste this thing. So if you see, the number of values are increased because we are running the container in a privileged mode. So this is how you can identify multiple processes which are running within the container. You can come here, you can find the process ID, you can check out its status and identify what kind of capabilities that specific thing is having. So let's say there is some feature called cap drop when it comes to Docker. So what this will do is it will drop all the capabilities for this specific container. So now let's see what will happen if you drop everything. So ideally we have seen some 2 lines when we are running the normal Docker run command. So let's say if you are dropping all the capabilities and doing sleep for 3 days. Now let's say you are looking for it again and sleep 3 days. The process ID is 911138. So we can just go back again, grep cap 911138 and status. You see all the values are 0. So in case, so to explain in real world terminologies, if this is your application, web application running, and if you are exposing it to the outside world, if this gets compromised for whatever reason, and if an attacker escalates or leverages this process to come inside your container, he will not have any of these capability access. He cannot do any of these things. So if you do capacity decode, and now you just put in all the zeros, it will be blank. It does not have any capability at all. As you have seen, we have seeing these terms continuously. So we'll just understand what they mean. So cap effective is like the effective capability set that your system gets at a point of time. So whenever you're running more processes or if it requires more privileges, the effective capabilities value will change accordingly. And cap PRM is like the permitted set of capabilities that a specific process can use. INH is like for the inherited capabilities. BND is something which is important because it defines the bounding set of capabilities. So it restricts what's the maximum capabilities a specific process or container can have. And ambient capabilities is for non-SUID binaries. That is not something we are concerned at the moment. And also when we are doing this capability print, for example, if I look for print, you are getting so many things like cap chon, cap DSE override. What does this mean for us? For example, cap chon, the first one which we have seen. If you are having this specific capability, only then you'll be able to make changes to the file permissions. If you're not having this capability, you cannot make any changes to the file permissions. And similarly, DSE override. It is related to kernel permission checks and if you can make changes to these kernel files. Cap sysadmin, it is one of the most powerful capability where you can change the C groups of the system that will allow you to control the resources. So you can go through this above link, the capabilities manual. It will have all this information on these things. But for our use case, let's go with the simplest one, cap own. So let's see if we are not giving this capability to a container, what will happen? So for example, let's say I'm running this command, busybox, and I'm saying ping google.com. So once I pull in the image, it will start pinging google.com. Perfect. Because this is the default container and it has all the default capabilities. Whenever you want to use the ping command, it has to use the underlying network interfaces in order to send out the packets. So netroy is something which is responsible for these things. So what I am saying is drop this capability, netroy. And I'll execute the same command again. So if you see, it says permission denied. So this specific Docker container has everything else except this specific capability. So whenever the specific capability is missing, your Docker container or the processes cannot do these operations. So that's why the capabilities are very important, and you should understand what kind of capabilities you are giving to a container. So similarly, chown is something which is very simple. So we will see that as well. For example, if you see this command, we are saying docker run, and I'm dropping all the capabilities, everything back to 0. And I'm trying to change the permission of temp folder. I'm saying nobody should have access to this temp folder. Now it will throw some error. So if you see, it says operation not permitted because it doesn't have the capability. Despite Docker running as a root, I mean Docker daemon running as a root, and here Docker is also running as a root. But still, because the capability is missing, it cannot do the specific operation. So let's say if I'm running a normal Docker container, nothing else. So if I'm doing ch nobody, it will work. So what I'll do is we'll run the same command where we are dropping everything, but we will add only chown. We will not add anything else. If I'm doing this, it will still work because it requires only chown capability. For example, with the same thing, let's try it out. If I'm running busybox again, I'm running busybox because it is already having this ping command available. Ubuntu doesn't have it. So here we are saying drop everything, add only chown, and I'm trying to ping it. So now it should not work. And yes, it doesn't work because chown cannot work with the networking interface to design or craft the packets to make this request. And I have added some of these website links that will help you to understand more about the capabilities. So depending on the kind of capabilities you are having within the container, it defines what you can do. For example, these kind of escapes. So these are all the commands that you can use to break out of the container and do the things. These all happen because you're having the capabilities. Like here you're saying if it is privileged flag is existing, they can run this command and directly break out of the container. And similarly, each and every capability that you saw over here, like if I do capsec print, it is having unique feature, and you can do a container breakout with each one of them. There are different kind of techniques available to break out of these systems. So you can have better understanding over here. For example, Pentester Academy, it is one of the famous website where you can practice these kind of things. Let's say there is a sys module capability. So they are breaking out container completely using that. So they have their own exercises. So they have written a write-up. For example, this is how it works. They write a reverse shell in C language, and then they try to execute these commands, and then it will break out of the container just because it is having a capability which is not supposed to be there. So you can read more about it later on. So that is about capabilities. And similarly, Docker socket is something we have seen before, but we will try to explore it in a hands-on scenario right now. So we got this Kubernetes Goat. This is one of the other playground where you have multiple scenarios. It is a vulnerable by design cluster environment where you can practice all these kind of vulnerabilities, attacks, and everything. So we will try installing this command. For some reason, it might or might not work on killercoda. Sometimes it works, sometimes it doesn't. We'll just try it. If it works, it's fine. If it doesn't work, then you will have to do it in your local environment. So we will try exploring more about this Docker socket through this scenario. Okay. So this is something I have done when I was showing you the real world pen test or real world attack scenarios when we were playing around with Shodan. But here we will do a hands-on scenario so that even you will get a good understanding on how it is done. Okay, it is taking quite some time. And we can go to, okay, let's just give it a minute, and in the meanwhile, we will understand what. Okay, let's see this one. Now I'm saying setup. So if you are running on your local machine and if you are having kind installed, then you can run this set of commands for the installation. If you're having a normal Kubernetes cluster, this should work fine. So once everything is done, we need to expose the services through this thing. It is taking a bit of time. I think I already have this on the local host. We'll just go through once you have it installed. So once you have the specific Kubernetes Goat environment set up, I'm not sure why it is taking this long, but let's just give it a minute. It should be fine. In the meanwhile, you can go through the things we have discussed so far. Now I'll say access Kubernetes Goat. But in the meanwhile, we'll just try to see if all the services are up and running or not. Because if these containers are not up, there isn't much we can do. Okay, running, it is creating. So not bad, it is created multiple things. So once this is done, you can go to this traffic or ports. And then you can access this port 1234. Okay, it is coming up now. So not bad. So there are multiple scenarios that you can play around with. But for now, we'll pick up a handful of scenarios for this workshop. So if you see Docker and Docker exploitation, it says access this port. But we are not on localhost. So what we'll do is we'll come back here. You can change the port to 1231 and click on access. So this is how it works in real world. You'll have a web application or something which you'll get to use, and then you'll have to identify or backtrack the things. So it is saying enter some server address. So let's say I'll write google.com and submit. So it is saying it is executing just ping google.com and it is giving you the output. So there is something called command injection. Let me just open it here. Let's see if we can find some images for the ease of understanding. Yeah, so something similar to this. If I just open this in the new tab, sorry. Yeah, it is similar to this one where we are entering the IP address and it will say ping and it will do the things. So now what happens is you need to analyze how the code is written on the back end. So if you have to build something like this, what will you do? So ideally you will be doing something like, I'll just zoom in a bit. Ping, you will say user input here. This is how in general anyone would write. So this will be like, let's say os.system, let's say it's a system call and you're running something like this. So this will work fine. If you're giving google.com, it will say ping google.com and it will execute it. Or if you are saying ping localhost, it will do localhost and work it. But the challenge or the thing would be if you are using Linux frequently. So what will happen is if you are giving a semicolon and then you write something else, once the first command is successful, the second command gets executed. So we will try doing something similar over here. So this is called command injection vulnerability. So let's say I'm saying google.com. I'll give a colon or semicolon and then I'll say ID. So it gave you all the information and along with that, it gave you the ID information as well. Because there is no validation happening on the backend. Whatever you are giving, they're just putting up here. So similarly, let's say you want to do google.com and list all the files, ls minus la. It will give you all the information on the files. So if you see, the entire thing is printed out. So this is just a basic thing. So in this way, you'll be able to, let's say, for example, print etc password, and you'll be able to get the username, passwords, and everything. But let's try to make it interesting or understand this from Docker point of view. So now what we will do is, we will, right now you don't have a shell. You are just using this thing to do the job or something like that. So what we will do is, we will try to get a reverse shell, similar to the first scenario where I demonstrated. We will have our own. So in this one, maybe you might not be able to do hands-on, but you can get an understanding. So let's say I'm having my own server with this IP address 18.14.250.7, and I'm saying I'm listening on port 8888. So now what I will do is, we have tested these things, or for example, to explore more, let's understand what's the host name. So this is the host name. So we are not running as a root user. This looks like, a few are familiar with the naming convention of Kubernetes deployment. This is how it looks like: deployment name hyphen replica set ID, and then you'll get a random value. So this is a pod, and if you are getting some access, it will be inside the pod. You won't be on the host machine or something. If I do who am I, it says I am a root user. So now what we will do is, we'll come back here, and then you can use this command. In this case, I have this server up and running. In your case, it can be any of the public IP address. So what we are doing is, we are saying open a connection to this IP address on this port, and we are storing it in a file, run.sh. So I'll just copy this command, go here, paste it out, and then I'm just printing it again, printing the file to make sure my data is stored in it. So if you see, we have this printed out. So with the echo command, we are storing the information here, and then we are just printing. Now what we will do is, we will try to change the permission to executable and try to run it. As of now, if you see here, there is already some other process running, so we are getting the shell. So what I'll do is, I'll make the port number to 8887. And in that case, what I'll have to do is, I'll have to change this command as well, instead of 8888, because something is already running, 8887. And once I have that, I will execute that file. When I run bash temp run.sh, it will trigger the file, and in turn, it will trigger this specific command. If you see on the top, it is still going on. It is never ending. That's because I got a connection over here. So if you remember the host name, it was health check deployment something something. And right now I got a shell from there. So if I do who am I am root, and if I do the host name, it will be health check deployment, something like that. So now once we have access, we are inside the pod right now. Like we have told, this is how the generic structure would be. So now, for example, what we can do is, you can use this command find / docker.socket. So it will identify for the Docker socket. So if we are having a Docker socket mounted, so if you see here, it is mounted in a different location /custom/docker, which is not the standard location. So if I use Docker or something, let me see. So Docker is not existing. If I do an apt update to install Docker, it says invalid operation, or it is taking some time. So what I will do is, I will download the Docker binary directly. So we'll dump the Docker binary. So once we have the Docker binary, we'll have to unzip it. It will take a bit of time, and hopefully, okay, this is having some time left. So it will take a bit of time to unzip, and then we will have a Docker binary in the system. And then what you can do is, you can leverage this Docker socket on this custom location. Since it is a socket, this is how it works. you'll have to use this format. For example, for HTTPS, if you see here on the website, it will be HTTPS semicolon and two slashes. But when it comes to the sockets, this is how it works. You'll have to mention Unix, and then you need to specify two slashes and then the path of the file. So let's see if this is done or not. Okay, it is done. So now everything is extracted into a Docker folder. So I'll say change Docker. Okay, I'm spelling wrong. Now I'll do ls. It has multiple files. So I'll do /docker. It is working. I'll do docker ps. It will not work. If you see, it is saying like it is looking at the standard location /var run docker.sock, which doesn't exist because the file is copied to a different location. So you can copy this command, because when we done the find command, find name docker.sock, you can see it is at this custom path. So now we have this information. So we are saying docker -h custom path. When I do ps, it's not showing anything. So similarly, let's try maybe because ps it's not having anything, but maybe images it might be having any. So we'll go and check /docker. Okay, maybe I did not copy the dot. Copy the complete command again. So this is how you can use the Docker socket to list all the things which are running on the host machine. So in this case, it should show the things, but I guess there is some connectivity issue and I'm getting these things in between. But it will give you all the information of the Docker things which are running. So similar to how I have shown in the beginning, you can run your own custom images or you can run your own containers, and then you can mount the host machine, change the username, passwords, everything. So for example, this mounting of Docker socket is a very bad practice, as you have seen here, because we'll be able to list down everything. So I have done a small search on GitHub. So if you click on this link, so what it will do is it will take you to GitHub. Now, if you see the search query, I'm looking for var run Docker socket, and I'm looking for this file docker compose.yml. So there are around 25,900 plus repositories in which they are mounting the Docker socket. So whenever these things execute, and if any of their services get compromised, their entire system will get compromised. And one of the thing is something called Kiwi. There is Kiwi Kafka. So for example, if I look for Kiwi Kafka, it is not showing, but I have tried this one. I don't know, it was just a random repository that I found here. If you go to the second page or something, there are 25,000 such things available. So now what you can do is, for the test purpose, you can just try to clone this repository in the killercoda. So you can pick any of these 25,000 repositories. Now the result is increased. It says 49,000 results. All of them are vulnerable. Like if something of them get compromised, it is gone. So you can go to Kiwi Kafka, and then it is inside this scripts folder, if I'm not wrong. Yeah, inside scripts, it is Docker Compose Kiwi. So there is a Docker compose.yaml. So if we see that, so here, if you see the volumes, it is mounted. So what we can do is, let's try to get this up and running. think it might take some time over here. Let me just try running it on my this machine. Ah, come on. Yeah, so here it's a bit faster. I go to scripts, and if I say docker compose, so what I can do is if I give docker compose up -d, it will get it started and it will take it to the background. So we'll just give this some time and then we'll come back. So similarly, like privileged flag, which we have seen, and regarding these reverse shells, there is an amazing blog here where you can get different kind of reverse shells. So in different languages, like right now I have used a Bash reverse shell. Similarly, you can get for Golang, Netcat, Node.js, Perl, Ruby, Java, everything. So if you are more interested, you can just go through this thing. So as we have seen, privileged flag is taking something. Similarly, there is something called hostPID. By default, it is false, but whenever you are putting this hostPID as true or something, then the container will have more access to the all the processes information that are running on the host machine. Similarly, host IPC is something which will give the container access to inter-process communication. Usually the IPC shared memory is this location, so they can understand what kind of communication is happening with the host and the other systems. Similarly, host network, like we have mentioned, there is an isolation. Whenever you create a container, there will be 7 set of isolations that will happening, like this one, PID user network. So there is a network isolation, but whenever you are using the host network flag, then the host, all the interfaces of the host machine will be available within the container as well. So these are some things that you can play around. Or so whenever this happens, your container will not have any unique IP, and also you can dump or intercept all the traffic that is going on the host machine and the other systems. So okay, if you see this thing is done, if I do a docker ps, for example, so it is running many things. So what I'll do is I'll just try to docker exec into one of the systems, maybe Kafka 3, and I'll do bash. Now let me see if I have docker in it. If I do docker ps, see right now I am inside the container, but I am still able to do docker ps or docker images, everything, and I'm able to see all the information as well, only because this specific where run docker socket is mounted in this Kiwi Kafka. So all these applications that you are seeing here, all of them are vulnerable. Every single one of them, there is no exception. So if someone is getting access to these files or this kind of container, so right now this is running within my system. So let's say if this Kafka thing, like we have seen Docker PS, the Kafka part, if it is exposed to the outside world, then it's just, and if that gets compromised, they will come within the container, they can run all these commands and they can create all the chaos. So how do you identify whenever I'm saying if this gets compromised, this can happen? So how can you identify these kind of compromises or something? So for that, we got a nice tool called Trivy. It is an open source scanner for vulnerabilities. So it will scan all the Docker images and it will list down all the vulnerabilities. For example, let's try to nginx. That is some image we have used today a lot. So let's try scanning that image. So I'll come back to this cutup. I'll just killercoda, I'll refresh it because the time is almost out. Okay, so I got this. I'll move this to this side. I'll see if I have Trivy installed or not. So first we need to install Trivy. So the installation is also quite simple. It's not hard. we can just go to the releases section. You can identify Linux 64 Debian. Just wget it. And then you can say dpkg install trivy. So now we got trivy, and I say image. I is for image, a shortcut, and I'll say nginx. And you can see it, nginx image, which is quite famous and everyone uses. Like if you go to Docker Hub, for example, the official image of nginx, it should have more than 10 million easily. I'm just guessing. Okay, it is having more than 1 billion downloads. But still it is having these many vulnerabilities within that image. So any of these can be exploited by an attacker or anyone. So similarly, if you can scan any images, you can use trivy and you can use some ubuntu image, for example. See, even the ubuntu image is having these many vulnerabilities. Like if you scroll to the top, it will show you the exact number as well. But let me just try scrolling to the top to give an understanding. So I have to continuously keep scrolling. The list is that long. Okay, if you see, I reached to the top, but here it's not showing up. So the list is quite huge. And since you have recently learned argocd in one of the workshops, so what we will do is we'll try to do a trivy scan on the argocd images. So we will do it on this machine because it has to build it again. So let's say I go to a temp directory and as I get clone argocd. So once we have the argocd image, so what we can do is you can just go ahead and see, even this is one of the most famous projects. If you see, like there are 10K stars and everyone uses it across the world, and there is a Docker file in it. So what we will do is we will build this from scratch. So we will say like Docker build and we will build the image. So the download is done and I'll say argocd. And now if you see here, there are many files and everything available. So what we will do is I'll just edit the Docker file because when I was testing, I observed there is a build platform flag that is breaking the build. So we will just remove that build platform. So here you can see the platform -- build platform. And just, I think my shell got messed up when I got the reverse shell. I'll just refresh the page so that I'll get a new shell. Okay. So if I go into the temp and if I go to argocd, so we can go to this Docker file again. And if you see here, there is something called I'll just try it here itself. For some reason, the shell is not working properly. But it will not work in killercoda because it requires more space. And here, let me see if I have argocd. Let's try it here. Yeah, I'll build here because I fixed this file already. So now if I do a Docker build argocd, it will download all the things that are required and then it will build the image. So once it is built, you can even scan the local images. It doesn't have to be available on the public repository or something. Ruby picks that up. It's taking some time and now it says it is done. So now I'll say trivy image argocd. So now it is downloading something and if you see it, throws so many vulnerabilities. I'm not even sure if I can go to the, okay, I can go to the top here. So if you see here, we scanned here trivy image argocd, and then it throws all the vulnerabilities. It is using Ubuntu 22.04, which is having 28 vulnerabilities. And similarly, it is having a binary. The binary is also having some vulnerabilities. It will give you a very detailed information on each and everything. So the reason of showing this argocd specifically is, if you go to the Docker file, you can see there is something called base image. And here it is using Ubuntu 22.04. So what we can do is, if you are changing this base image, the number of vulnerabilities will decrease. For example, if you go to this page again, and if you see this one, if you are scanning for Ubuntu 22.04, we have already seen there are like many vulnerabilities, like there are 26 vulnerabilities it is showing. Similarly, if you scan a different version, like maybe 21.04, see, it is not having any kind of vulnerabilities at all. So in these cases, what you can do is you can try to modify the base images whenever you are trying to deploy argocd or some kind of third-party application. And if it is having multiple vulnerabilities, you can try changing these images, and then that will reduce the number of vulnerabilities. You can try changing this to 21.04, rebuild it, and then scan it, and it should give you the result. And similarly, there are something called distroless images, which are like a complete blank images. It's like a blank piece of paper, and whatever you put in it, it will have only that specific thing. So for example, if you see there is some image, if I just scroll down here, it will have many images as an example. You can use any of these things. So I picked up randomly this one, static Debian 11. So if I go to trivy and if I try to scan that, for example, see, there are no vulnerabilities. So you can use this image. So when I say distroless, what does that mean? So it will not have anything. For example, you can do this docker run command, and we try to do ls. We will see if we can list all the files in it. So it says ls executable not found. And similarly, if I do id or something, so it says id not found. Or if I try to get a shell, for example, it says sh not found. It will have nothing. It's just a blank page with very limited kind of information with no executables that will allow you to copy your binaries to this specific image and then execute it. So in this case, you are reducing the attack surface a lot. So it won't, even if this gets compromised, an attacker cannot do much. Like if you see in the above scenarios, I try to get a reverse shell and then try to do these things. But if the image is not having anything, I can never get a reverse shell. I cannot do these things. So similarly, there is something called, you can analyze these Docker images as well. Sometimes these Docker images will have malware embedded in it or crypto miners embedded in it. You just do Docker run and it runs on the background without you knowing. For example, if you do Docker inspect Ubuntu image, for example, it will throw lots of information as expected. But this will not give you a detailed information on what is inside the image. It will just give you a metadata of the image. So there is an amazing tool called Dive. So this is like a amazing tool that will analyze each and every layer of your Docker file, and it will give you the information. So first we'll just install this Dive, and then we will understand, or we'll try to come up with a use case where we can use this thing. So you can just, I have given the commands where you can just wget the Debian file and then install it. And once you have it, we will need this. There is a Kubernetes Goat scenario that we can leverage, or alternatively, it internally uses this image. So what we can do is we can just pick up that image directly. And we'll try to analyze this image. So we'll say docker pull, we'll have this image. And now if I do a docker inspect on this image, the best you can see is only the metadata information, like what is this upper directory, lower directory, what kind of layers it is having. But what is there in this layers, you cannot know. So that's where this comes in. So since this was an intentionally vulnerable application, the Kubernetes Goat, we have embedded a flag in this specific image. So what we can do is you can try to dive into this image. So it is simple as this. You can just say dive and the image name. And see on the left side, it will give you all the layers information. And then on the right side, it will give you all the contents information. For example, if I just do the down arrow, so there is a line where I'm saying add secret.txt. And then it is, and then in another line, it just says like echo contributed by me and other things. But this secret.txt is something interesting. And we want to see this, for example. So what we can do is, let's say docker run. We'll try to run this thing, docker run -it, get a bash. There is no bash in it. Let's say sh, sorry, give a space. So if I go to root, there is just contribution.txt. There is no secrets.txt file here. So if I do -name secret.txt or secrets.txt, I don't remember the name. It's not having, if you are coming inside the container, it's not having that thing. But when you analyze each and every layer of the Docker image, it might have some sensitive information, like there is contribution.txt, but it is not the one which shows us something, or it is not the one which is having some sensitive information. Okay, it is inside root folder. Now if I do contribution.txt, it just says contributed by this. So now what we can do is we can go back to dive again. And if you go to add secret.txt, you can use the tab to go to the other right side of the pane, and you can use the page down arrow. So if you scroll completely down, so if you see here, it has an amazing color coding feature as well, where it says this root directory has been modified, and it is having this secret.txt available here. So now how can we read this thing? Because in the final image, this is not existing because it has been removed somewhere. So now what we can do is all the images, they are eventually tar files. They are just like a zip of some files. So what we can do is docker save is the command that we can use. And then we will save the image into a tar file. So whenever you run this command docker save, it picks up this image, gets all the layers and creates this file. So now we have this file hidden in layers.tar. So now you can extract the information of this hidden in layers.tar, and then it threw multiple information, like it created this directory, this directory, this directory. So if you go back to dive again, and if I go to this second line, because we are most interested in this secret.txt, if you see there is an ID available for that layer, 2a something. So here, whatever got extracted, 2a something, this is where your information is lying. So you can just change directory to 2a27 this thing, and then do an ls again, and there is another layer.tar. So you can extract it again. Now it gives you this root folder and whatever files are available in that layer. So you can do cat secret.txt, and here you get the flag or whatever the sensitive information is. So by using tools like dive, you'll be able to extract each and every layer of information. So based on this, there is even a scenario in Kubernetes Goat where you'll find the crypto miners as well. So they will code some crypto miners within this application that cannot be accessible directly. So This is how you can analyze everything within the container or the image. So similarly, we have something like memory limits when it comes to containers, which is quite important. So you should always set up the memory limits. So we will see what will happen if you don't set the memory limits. So this one, don't run on your computer. If you run, it will completely crash. All the resources will be consumed. So this is called a fork bomb. So what it will do is it will continuously spawn multiple containers or images, multiple processes, and it will consume all your resources. So for example, since I am on killercoda, I can try this thing over here. So you can run it here. So if I just copy this thing, I paste it here, and within next few seconds, everything will get crashed. You see, resource temporarily unavailable. I cannot do anything. I cannot stop it. I cannot restart it. Nothing. Like, I mean, I can refresh and get a new shell because I'm on killer coda. Else you'll have to restart the system and do a lot of things. So how does this correlate with Docker? So let's say you are running Docker here. I'll just close this thing again. So here I am creating an image container with unlimited name, and then I'm running the Ubuntu image. And also I'll open a new terminal on the other side where I'll print this stats. So Docker stats command is something that will give you the statistics information of this specific image or I mean machine. So in this case, this specific container is having the limit of 1.94 GB of memory. And now whenever you run the fork bomb, if I go to this thing, see the memory usage is increasing continuously, CPU usage increased, and it will hit the roof and then it will stop working completely because there is no threshold limit and then you can never access. So even here it started. So even if I try to create a new tab or something, it will cry after a while because of this memory limits and other things. So what you can do is, in order to fix these kind of things, you should always make sure you are putting in some limits. For example, if you see here, I created another image or container with limits, and then we are doing this thing. So if you see, the limit right now is 512 MB only because we have specified it when we are running this container. We are saying memory is this, CPU cores is this. And now if I run a fork bomb in it, for example, I don't have to worry much because the maximum it will hit is this limit, and it is already hit. That's why it's all the numbers have been changed. But still, I'm in a position where I can terminate this, or I can create new processes, and I can kill this thing also. I can do ls docker ps. I can do all kinds of things, and it will work just fine because we have the limit. So this is something which is important because if you don't do this and if an attacker gets access to the system, he can just DOS your entire system and it's gone. And similarly, we have a challenge on Kubernetes Goat itself. So you can install the Kubernetes Goat since I have already running on the local machine. I'll just show this challenge. For example, attacking private registry. So this is the challenge. Private registry is something where you store all your information and sometimes it gets misconfigured easily. So the scenario is hosted in this specific location. So if you just go here, there is nothing, it's just blank. So if you view the source or something, you won't see anything. So what we can do is there is a Docker registry specification document where it will show you all the information related to how the API structure is. So it is saying everything is under v2. So what we can do is we can go back here and we can say /v2. So right now it throws blank. So let's say you want to list all the images. So there is something called /catalog. You will get this all information in this page itself. So listing repositories. So you need to hit this endpoint. So here it says there is image Madhukula, Alpine or K8's repo. So since this private registry is not authenticated, so you will be able to access all these things. For example, if I'm using my local machine, just zoom in a bit. Let me just check. Preferences, font is 16. Yeah. So for example, I'll just copy the same URL again. And then I will do the same command which we executed, curl v2. It throws blank. And I say catalog. So it will say all the list of repositories available. So let's say you want to analyze this specific image or understand more about it. So you can do curl v2 image name slash manifest, send the tag name. Here there is nothing mentioned, so it's latest. So if you see, it throws lot of information similar to Docker inspect. It will have all the information available, and it will give you what kind of history or what kind of commands have been executed and everything. So sometimes what happens is within this manifest itself, there will be some sensitive information leaked by developer or something. So if you can see, there are some API keys, GPG key in the environment variables. So you should never store any environment variable when it comes to Docker files. So this is one of the important thing, because people often assume whenever they are writing something in the Docker files, it won't be reflected within the container or something. But this kind of things can happen, and private registries can be exploited as well. So whenever we say Docker files should be write securely or something, how can we do that? So there is this amazing tool called Docker that you can use to scan all the images for vulnerabilities, not vulnerabilities, for bad practices. So you can run this command to install it. For example, if we install it here, it is installed. So we'll use the same image that we were analyzing previously, Docker and the image name, that's it. And it will say what are the kind of issues with this image, like what are the best practices that are not being followed. First thing is, last user should not be root. This container is run as a root, and it should not have this latest tag available. There is no health check. And most importantly, if you observe, I remember seeing some environment variables as well over here that will give you the flag information. For example, if I do grep env, see, it is one of do not store credential in environment variables. So Docker is capable of identifying sensitive information as well within your environment variables. And similarly, you can scan all the Docker files and everything using this tool, and it will follow the standard practices. So this one is really helpful when you want to analyze an image or understand what kind of things are happening over there. So these are all for the static analysis, like you are doing something at runtime and it is happening. For example, there is something called Falco. It is also one of the best tool for runtime security. So you can configure rules that you can identify whenever some specific set of operation is happening, even within the container. So let's say, for example, first we need to install Falco. So you can use this commands to install Falco on this killercoda. Okay, it is done, and you can just run Falco to run it. So right now it is running. What this does is it will observe all the system calls that are happening on your machine, and then based on some rules, it will say if something is going wrong or not. For example, so let's say we have run this, and then I'm running a, if you observe this command, it is docker run. We are saying nginx container. We are just running in the background. We did nothing. So once it is done, you can do Docker PS, and this is the container that is running. So if you go to this tab, there is no identification or something. So for example, let's say if you want to exec into the nginx container. So whenever you go inside it, it will trigger an event. It will say a shell was spawned in this container. It will say the username and it will say the container name. If you see the container name over here, A0B of something. So that's the container name here. And these are all the things. For example, let's say if you are seeing the password, it will not throw anything because password file is not sensitive and it's globally readable. But if you are seeing the shadow file, etc shadow, which is considered as a sensitive file, it should trigger an event over here. See, warning, sensitive file open for reading. So what happens is whenever you are running Kubernetes, you'll have numerous number of containers within your environment, and it is very hard to understand or analyze these things. So which container is doing what operation? So that's where Falco comes in, and it will do this kind of things. For example, if an attacker comes here and if he tries to change the password of this root user, so then an event will be triggered. For example, since we are on killercoda, I'll say some random value and I'll write this to etc/shadow file, which is a sensitive file. So now if I go back here, see there is an error. So if it is a read operation or something, it will throw a warning. And if it is an important thing, it will throw an error. It says etc shadow file has been opened for writing and someone has written to it. So whenever you get an alert, you can integrate with this with your SIEM or some alert management mechanisms. So you'll get an alert immediately and understand like something is wrong with this specific container or something. And you can create your own rules as well. For example, if you see rules are loaded from this location. So if we go to this location, etc falco, it might be in some other location. Whenever you're running within the container, it will be in this location. So you can write your own custom files as well. You can write your own custom rules and you can do the things. And also I have referenced another nice website, not website, it's a repository where you have multiple podcasts, webinars, and how you can configure falco and how it helpful in runtime security monitoring. So you can try this out as well. So last but not least, when it comes to the containers, there is a standard NIST framework. So what these guys do is they give the best practices for all the current existing environments or this applications like Docker, cloud, everything. So you can go through this specific NIST document where they will mention about multiple things like image vulnerabilities or what kind of clear text passwords, registry risks, runtime things, and how you can mitigate them. So this is like the complete guide for container security or what kind of things can go wrong. So you can see there are some examples as well: running a poisoned image, exploiting the container runtime, exploiting a vulnerability within the image. So you'll have them all. So this is definitely worth checking out if you are exploring container security. So similarly, this is what we have seen with containers, and whatever we have discussed in container, everything, every single thing is correlated to Kubernetes, because in Kubernetes you will eventually run pods which in turn run containers. So making sure your pods are not running in privileged mode, making sure they are not having limited capabilities or they are not having wide range of capabilities, those all things can be configured from Kubernetes. And also one of the other important thing when it comes to Kubernetes is RBAC misconfigurations. So assuming you are already familiar with Kubernetes, RBAC will let you define the role-based access control. It will say which user is allowed to do what. So this is also another scenario from Kubernetes code that we can use. For example, if you access this page in port 1236. So if you go to 1234, you'll have all the descriptions. So let me check if there is a RBAC thing. Yes, RBAC scenario. So here they are saying an attacker got access to the specific machine, and there is some misconfiguration when it comes to RBAC over here. So how can an attacker leverage this thing and do this escalation? For example, if you see here, I'll zoom in a bit. Again, you are within the container. Like you can check this var lib docker like I told before. So you are definitely inside a container. And since this naming convention we already know, we can be sure it is running on Kubernetes. So you can check for other things like docker.socket, which we have done already. And it says it cannot find any Docker socket. So even if you do a Docker PS or something, that will not work because it eventually requires the socket. So how can we explore this more? So there is something called service account mounting that happens when it comes to Kubernetes. Whenever you run an application on Kubernetes, like for example, I'll kill this falco. So once you kill it, it will even show what kind of things that happened. So if you say kubectl run nginx, image nginx. So kubectl get pod. It is creating. So what you can do is, let's say, you can extract this into an YAML file, and I'll save it in a file here. And if you come here and you explore more, there will be all the information related to service accounts. So for example, here it says service account is default and service account name is this that it will be using. So the same happens over here. So what you can do is, this will be the standard location where all the secrets are mounted. So if you see this YAML file, volume mounts, so you can see the things are mounted into this specific location, service account, and it is having this information. So the same happens over here, but since we are inside the container, we cannot see it. We'll just say change to the service account location. Then we'll do an ls. It did not change because ACCOUNT spelling is wrong. And now if I do an ls, I see these 3 fields available. So what you can do is, all the information is stored in your environment variables. There are multiple information that gets automatically filled that you are not aware of whenever you run a Kubernetes service. And it is having all this information here. What we will do is, we will extract the API server information. So if I do this thing, and if I do echo $API server, it will have the API server information. Similarly, we can extract all the service account namespace token information from here. And as you know, when it comes to Kubernetes API server, it is an API server. You can just make curl request to the API server to do the things, but you need to get yourself authenticated. So that's where the CS certificate and the bearer token will be helpful, which we extracted from the above steps. And we'll try to hit the machine. See, now within, you are in the container, but still you are able to run or hit the Kubernetes API server, which is running on the host machine, and extract all the information. So similarly, you can list all the secrets as well, because eventually everything is an API call. Whenever you are running, for example, kubectl get secrets, in the background, it will be an API call to the server. So you can run the same thing, but here it says secrets is forbidden for this user. So they have an RBAC control. They are saying this specific user cannot list all the secrets. So what we can do is, we can try to list the other secrets in different namespaces. For example, if you see, this is the namespace, big monolith. This is the structure, system, service account, and then the namespace name and the service account name. So it is unable to list secrets in this monolith namespace. Let's try to list the secrets in some other namespaces, for example. See, now it worked out, and it is listing out multiple information on all the secrets. And similarly, you can get all the information, like if you see here, API v1 namespaces, and we are listing down specific namespace secrets. So here it is not able to list all the secrets of all the namespaces, but when you mention the specific namespace, it is able to list it. So similarly, in specific namespace, we can try to list down all the pods as well. So you can just copy this command, and if you run it over here, it will list down all the pods, and see it is saying this image is being used, hunger check something. And similarly, there will be multiple other images information available on the top. But since our target is secrets, so if you analyze more of the secrets file, then you will see like there are some API keys available. And as you know, whenever the secrets are being stored in Kubernetes secrets, it will be in base64 encoded format. So even this one is the same. So what you can do is you can copy that and you can do echo that specific field and base64 minus D. So then, as you can see, it will give you the information. It will say this is the Kubernetes Goat flag or something. And similarly, we have some other keys as well, API key and everything. This is the vault key. There is some API key as well that is left out in the Kubernetes secrets. So even though you are running or you are existing within a container or within a specific deployment, you are still able to go out, access or communicate with the API server and then do these things. So how is this happening, or how these kind of things can be prevented? So by default, all these things are mounted. So for example, you can run this command on here in killercoda. There is a flag called auto mount service token. So if you are setting this to false, so if you remember, we copied this file here, and if I look for this auto mount service token, it's not there, because by default this is true and you need to explicitly mention it as false. So when you mention this as false, and if you try to make a deployment, then these kind of things will not happen. It will not mount all these secrets or these tokens into the container, because usually whenever you run a pod, it doesn't have to communicate with the API server. It doesn't have any use case in general. In some cases, it might have a use case. In that case, you'll have to make sure you have the proper RBAC controls in place to do these things. And also here you are seeing, if you are doing kubectl explain pod minus minus recursive, it will list down all the fields available for the pod API resource or CRD. So now I'm saying, if I'm saying the same command and if I'm grabbing for auto mount, it is very hard to understand which field it refers to, because if you see the YAML file, it will have multiple fields. It will have these many. So how can you identify where you need to insert this specific auto service token, auto mount service token? So for that, what we have is we have another thing available. So there is something called crew. It is a extension to kubectl. It will allow you to write your own custom plugins for Kubernetes CLI. So for example, you can do this command to install it. We'll just install it for the moment directly. And then this is one of the plugins that I have created long back, where it says kubectl-fields. And then once you have this crew installed, you can run this command to install this specific project. So what this does is, it will help you to identify the fields properly. Like if you have seen here, when we did a grep, it is very hard to understand where you need to put this field. But with this extension, you can say kubectl-fields. Let's say in pods, you are searching for auto mount. And just paste it out. And then it will say inside spec, you need to put this auto mount service token. So when you go back to Vim or something, so it's much easier for you. So you can just go into spec, you can add a new line, and you can put here auto mount service account token, like that. So similarly for other things also it will work, kubectl-fields, and let's say if you are looking for mount points, mount. So these many mounts are available, like directly you can say auto mount service token, that is something we saw. And similarly, inside containers, you can look for volume mounts. Inside init containers, there is a security context where you are mentioning proc mounts. So similarly, you can visit the crew website where you will have multiple plugins available. Or I think even you can do kubectl crew list. It will show all the installed plugins, but similarly, there are some other commands which I don't remember that will list all the available plugins also. So this is something you can use to easily configure or modify your YAML files to understand the hierarchy of the fields. And similarly, we got network policies. We are almost closing, so I'm just not taking any break or something. So we'll discuss on a couple of other things and then we'll wrap up. So similar to firewall, if you have seen here on the top, we were understanding or we were seeing how to get a reverse shell. So in real, we don't have any firewall as of now. But when it comes to Kubernetes, it will help us. There is something called network policies that will help us to understand how we can block the communication. For example, the very basic one is deny all traffic to the application. So I think there should be some nice animation. Maybe it's in the other thing. Yeah. So here it says limit traffic to an application. So you are having this application and you are saying only it should allow traffic from a specific pod. It should not allow from anything else. So in that case, you can apply this network policy where you can specify the matching labels. So whenever you say match labels, app, bookstore, and role API. So this rule will be applied only on a pod with these specific labels. And then it will allow you can mention from where the traffic should be allowed. So we'll do a hands-on thing quickly to understand. So we'll just pick up something much more simpler. So let's say deny egress traffic, external egress traffic. So in this, we are saying there is no traffic that is allowed outside. So you can just copy this network policy. You can come back here. You can paste it as netpol.yaml or something. You can paste it out and then you can say kubectl apply netpol.yaml. So now we have created this network policy. So what this is doing is, if there is any pod with this label app as foo, it is blocking all the external communication. This port 53 is used for DNS resolution. That's the only reason it is there. So now let's say if you try running this command, we are running a nginx image and we are having a label and we are saying expose it on port 80. Now once we have it, we try to hit this specific, sorry, I copied many things. So now we are running an Alpine image and we are getting a shell. So from here, we will try to, since it is an nginx, it is running on port 80 and we are also exposing the service. So it is directly accessible. So if I try to hit this specific port, it will work because the label is mentioned as app foo. But when you try to do some external connectivity, let's say google.com, this one will not work. It will say timed out. That's because here you are saying the traffic is allowed within these namespaces. Namespace selector, you are saying everything. So all the inter-pod communication is accessible, but whenever you try to make an external connection, that's what egress does. Egress is external connectivity. So if I try to make a connection to Google, this will not work. But all the systems internally, they'll be able to communicate with each other. So if you observe, this kind of network policies will be helpful for us to block these attacks. For example, if you see this reverse shell thing again. So here what we have done was we have gone to this server that we are having. And here I have been listening for a specific port. I'm saying I'm waiting for some connection to come from the machine. So like mentioned here, where is it? Not this one. Yeah, this one. So here I'm saying I'm waiting here to get the connection, and the application is making the connection. But if you're having these kind of network policies where you're saying there should be no external connectivity for your applications, so then this my request would never get succeeded. So it will get blocked directly here. So that's how network policies will be helpful for us to limit the control or limit the blast radius if something happens wrong. They cannot do more of the things. And this is one of the amazing repositories from Ahmed, where you have multiple scenarios on network policies, so you can explore each and every one of them later on. And he has given even the uh, description of what this specific thing is doing, and he got some nice animations as well, where you can get a better understanding on the network policies part. So network policies is something that is important from security point of view. So similarly, this is one thing that we have discussed, and the next one is there is a this is one of the presentation that I have done long back, where even here in this case there is no network policies implemented by the company. So it is one of the pen test scenarios where I was able to compromise $1 million company, and I was able to gain multiple things. Like there was a SQL injection from there. After some enumeration, we got SQL injection. From SQL injection, we got remote code execution. From there, we bypassed the antivirus to gain some access. So all of these things happened because I was able to get a reverse shell from the system. Like if you see here, like somewhere in the down, uh, I think maybe came a bit forward. Yeah, this part. So this is how the application architecture looks like. So this is the attacker, and then we have a web server running. We got the database. I made some request to the web server. Web server is forwarding it to the database. Database is processing it. And once it is processing it, it is sending back the results to the web server, and web server sends to this. But the problem is if you are sending out the SQL injection payload in such a way that this database will send a connection to the attacker. So here I'm getting a reversal completely. So usually in most of these scenarios, people will configure the ingress rules. It means they will block these incoming requests. But usually the outgoing requests, they allow as it is, or they don't put any whitelisting on this thing that will lead to this connection. So if you're having a network policy, it is capable of blocking these connections as well. And if you're not having this connection, there is nothing much you can do, or it will take much more time for the attacker to enumerate the system. So network policies are capable of handling these kind of things as well. So last but not least, we have Kyverno. It is helpful for us to do multiple things on Kubernetes. Like it's a policy management tool, like you are seeing here. So let me just show the Kubernetes authentication. Maybe I should have some diagram on this webhooks, validating and mutating webhook. Yep, this is the one. So this is the usual path. Whenever a request comes to the Kubernetes API server, it performs authentication and authorization, and then the mutating webhook comes. So we'll not worry about what these things mean for the time being. These are series of checks that happen. And validating admission webhook is something that will validate your series of rules. So let's say you are saying a container should not run as a root. If you're applying that policy, whenever you try to run a container as a root user, that will not get deployed at all. It will get blocked in this layer. So Kyverno is something that will help us to achieve this same. So for this demo purpose, we will show a very small example where we will install Kyverno on this Kubernetes environment on killercoda. Okay, now we have Kyverno installed, and then you can just paste this specific policy. We'll go through what that means. This one is done. So now what we are saying is we are using the Kyverno's custom resources and we are creating a cluster policy and we are saying it requires a app label. So what this does is it will check for all the pods and it will see if this specific kind of label is existing or not. If it is existing, it will allow forward. If it is not existing, then it will block it. So we will just apply this thing, kubectl apply. Done. We have applied this thing and here it is saying the label should be starting with app and then it can be anything. So now we'll try to run an nginx image. So if you see it says admission webhook failed, denied the request, because in the previous diagram, if you remember here, it is installed over here and it is validating webhook and it is checking for the configuration that we have provided, require app label. It is saying label app is required, so it's not getting deployed. So now let's try to deploy the same nginx image with a different label, not with app. It is expecting app, but we'll see. I'm sending something random and I'm doing this thing. Even then it is not working and the request is blocked completely. So now let's try to give this specific thing that it is expecting. Now it says it already exists. So let's say if I just change the image name, instead of nginx, I'll say nginx random. So random is an inbuilt function that will generate random numbers. So whenever you are running this, it's useful for quickly spinning up multiple things rather than changing the names. So if you see, it worked out. It is running because it is having an app label. So this is just very basic example on this app label. So similarly, you can set for users. You can say memory limits should be there. If you remember the fork bomb scenario, which we have discussed, it says it must have this memory and CPU limits set. So for example, if you see kubectl-fields, pods and say memory, or I'll say limits. So you can set the resource limits for all these things. So you can add this kind of checks in Kyverno itself, saying this is a mandatory field. Like this limits must be mentioned. If not, do not deploy it. Or a container should run as a non-root user. If it is not that thing, block it. So this is like completely shifting the security to the left, like Sam has mentioned in the beginning. It should not be an afterthought. So even before you make a deployment, you are in a position to understand, okay, this is a bad deployment file. It should not be deployed. And last but not least, once you have done all these things, you need to understand how many vulnerabilities or the things that you are having in your cluster, like misconfigurations. Kubescape is an amazing tool from NSA where they will explain you all these things, or it will identify the misconfigurations within your system. So for example, let's say we will run the same thing since we already have a Kubernetes cluster here, we just install Kubescape. And now once we have the kubescape installed, you can go back here and you can do a scan of your entire cluster. So what kubescape does is it will scan for all the misconfigurations. It's a static set of rules. If you want, you can go and you can edit these things. And it will throw all the vulnerabilities which are critical, high. And since I zoomed in, it's not a bit clear. But if you are viewing on the normal computer, it says there is 25% risk. And there are different kind of frameworks available. So for example, what I can do is NSA framework is something which is very good. So you can do kubectl scan framework and you can say NSA, and now it scans for NSA framework only. And according to the rules provided by that framework, your cluster is 30% vulnerable or it's misconfigured. And if you add an option -v, it will give you a verbose output where you can go back and you can see all kind of critical information. Like if you go here, we can look for something critical. Everything is medium, low, medium, high. say application credentials in configuration files. So it gives you the specific name also, cluster info, kube public and everything. But the problem is, let's say you don't want to see anything in kube system namespace. You can even exclude that. There is exclude namespaces option. And now it will look only for the applications running in the other namespaces. And it will give you all the information on what is high critical. It says anonymous authentication is available. So if you scroll to the top, you'll have each and every information, like what kind of deployment. There is some issue with kyverno deployment. It says these are the misconfigurations in it. So that's how you can leverage this kubescape to scan your cluster for all the misconfigurations. And if you are installing this Kubernetes Goat, for example, it is having many misconfigurations. So right now, the default cluster provided by killercoda, it is 14% misconfigured according to this specific tool. So let's say if you are installing this Kubernetes Goat, okay, if you see this Kubernetes Goat, things will not get installed because our kyverno rule is in place and none of these things are having this app. So what we can do is we can just delete that file, kubectl delete check labels.yaml. That was the file. So now I'll just say set up Kubernetes Goat, and now everything is deployed properly. And now I'll run this scan. So now it increased from 14 to 28%. Now there are more resources which are misconfigured because it's an intentionally vulnerable application. It is having all these things available, like if you say privilege escalation should be false. In this case, it is true for this specific deployment. So it will check for all these things and it will give you a very nice detailed report. And you can edit the deployments once you see these things. So furthermore, there are things like AppArmor, SE Linux, mutating webhooks, seccomp, service mesh, observability tracing, and a lot more when it comes to hardening, observing, and maintaining a Kubernetes environment. So that is something which is more advanced or that can be covered in others workshops. And similarly, there is some article I have written on this webhooks. Since we have demonstrated the webhooks, you can see if an attacker is having access to your cluster, for example, he can create his own mutating webhook. So what that does is whenever you are running, if you are running an nginx image, for example, without even knowing, like you cannot know it, but in the background, for example, the same thing, Kubernetes webhook. The images, if we have seen this thing. So once an attacker gets access to your system, he can silently run this mutating webhook in the background and you will never know about it. But whenever you make a deployment, mutating webhook will take your configuration, make changes to it accordingly, and then deploy it. So if you see, I am running an nginx image, but whenever it gets deployed as a malicious image. So you need to make sure you have proper RBAC controls to make sure these kind of mutating webhooks are not being created in the environment, and a lot more. And also there is an amazing place called contained.af where you can practice your knowledge on this container security or the container internals. So it will ask you some questions and you need to solve some challenges. So this is something you can try it out, and also you can spin up in the local environment as well. Like there is a GitHub repository of them where you can spin up your own locally and you can practice these things. So that's a bit about introduction to container and Kubernetes security. And if you are having any doubts or something, you can always reach out to me on LinkedIn or Twitter, and we can discuss more on these things.
Yeah,
Over to
thank
you,
you so
Sam.
much. Yeah, thank you, Revant. I think that was a really, really insightful session. Thank you for preparing the material and all the real life scenarios that you demonstrated. Those were really amazing. And like Revant said, there are many other things that are there to understand about the security. So I gave a few sessions with SysDig webinars on CKS that covers a lot. Of different scenarios as well. So you can check that out. Couple of videos on my channel as well on Falco, and couple of other stuffs. But I think the hands-on workshop with the scenarios and real-world examples made it so much interesting. And thank you everyone who stick to the end. So I think that's very important. You people wanted to learn, and I hope you learned a lot. So do give a shout out to Revant on Twitter. His Twitter handle is displaying on the screen right now. You can directly do that, and do give him a follow as well, as he deserves that because he has given an amazing workshop. So thank you so much, Revant, for that, and thank you so much everyone for tuning in today. Make sure to let me bring my Cube Simplify workshops one. So make sure to go to cubesimplify.com/workshops. The next one is on Kubernetes troubleshooting next Monday by David, aka Rockcode. You all know him from his clustered series. So he'll be like giving all his experience learned from those hundreds of clusters breaking, and giving you all the feedback for that. Yeah, so amazing comments from the community, Revant, for you. So thank you so
That's
much for that.
awesome. It's pleasure.
Cool. Any last words for you from you?
Yeah, sure. So Kubernetes security or cloud native security is something which is widespread these days, and it is not something which you can cover in one workshop or two workshops. So this is subjected more on hands-on experience, and there are multiple resources available on the internet. So I would definitely suggest you to do a hands-on session on all the things that we have discussed. Only then you'll be able to gain better expertise at the things and gain more understanding on the internals of how things work. And yeah, that's it. And
Cool.
all the best for everyone.
Thank you all. And if you have any questions, you can reach out to Revant on Twitter. And yeah, thank you all.
Yeah.
See you in the
Thank you
next
all.
workshop. Bye.
See you all. Bye.